Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have completed chapter 11, three-dimensional geometry. Hope you have revised well. In today's session, we shall discuss a new chapter that is linear programming. Let's move on to the topic. We all come across many target-based situations in our day-to-day life. Can you think of any? Say a student has to complete a project in 15 days, or a salesperson has to achieve a sales target within a month. Another person has to buy an electronic gadget within a budget of $500. Go through these situations and try to find out the main objective to be achieved by each person individually. What is the objective of student in this case? He wants to achieve the maximum score in his project. The objective of the salesperson in this case is he would aim to achieve maximum possible sales in a month. The objective of the person buying the gadget would be minimizing the cost as much as possible. He buys a gadget which falls within his budget. We can see that in each of the cases, the objective of the situation was to maximize the benefits or minimize the cost. Such types of problems are called as optimization problems in mathematics. We have already discussed the objective of three given situations. Now we will look at the other important factors. We will identify the limiting factors in each case. In each case, there is a scarcity of some resource. In the first case, the time limit to complete the project is limited. Time to be allotted for completing the project is 15 days only. Likewise, in the second case too, time is the limiting factor. The salesperson has to sell the maximum possible products in a period of 1 month. In the third case, the person has to buy the gadget within a pre-decided budget. That is, amount to be spent is the limiting factor in this case. These limiting factors, that is, the scarce resources, act as constraints in finding the best possible solution of the given problem. In simple words, the aim of the optimization problem is to find the optimum solution subject to constraints of the given problem. This means we need to find the best possible outcome by allocating the scarce resources. But how are these problems are solved in mathematics? There are different problem solving techniques to solve such problems. One of such technique is linear programming. In this chapter, we will learn more about linear programming. Let's begin with the exercise 12.1 first question. Solve the following linear programming problems graphically. First question, maximize z is equal to 3x plus 4y subject to the constraints x plus y less than or equal to 4, x greater than or equal to 0, y greater than or equal to 0. Here there are three inequalities are given to you. X plus y less than or equal to 4, x greater than or equal to 0, y greater than or equal to 0. By using these constraints, you have to find out the maximum value of this equation. So let's write the given statements. Z is equal to 3x plus y, we have to maximize. And constraints are given to you, x plus y less than or equal to 4, x greater than or equal to 0, y greater than or equal to 0. Here there are three inequalities we have to represent. You have already learned how to represent the inequalities graphically in class 11. Same process only. Here x is equal to 0, y is equal to 0. Only one variable is there, so no need to prepare the table. But here there are two variables, x plus y less than or equal to 4. So here you have to prepare a table for plotting on the graph. So here first of all, we have to consider this an equation. X plus y equal to 4 we have to write for preparing the table. So just to consider x plus y equal to 4. This inequality symbol we have changed and to put it is equal to symbol. So it becomes an equation. Then we will prepare a table, that is just two values are enough. Simple values you can put. First of all, I am putting x is equal to 0. When I put x is 0, y is equal to 4. That is the first pair. Second, again y 0 you can put. So when you put y is equal to 0, x becomes 4. So that is 4 0 is the next point. So 2 points are enough to plot it on a graph sheet because we are going to draw a straight line. 2 points are enough. Then take your graph sheet, draw x and y axis and plot the points. While plotting points, just in your graph sheet what you can do is, here I am taking 1 unit as 1 centimeter as 1 unit. Here also same thing, 1 centimeter as 1 unit I am taking. But when you are drawing it in your graph book or graph sheet, you can consider 2 centimeter as 1 unit, so that your graph will be little bigger. So just to keep it in mind when you draw it. Then just to plot these table values on the graph sheet. First one is 0, 4. 0, 4 in the sense 0 is here, 4 is on the y-axis. So this is the point. 0, 4 is the point. You have to plot it by using your pencil. Then next is 4, 0. 4, 0 is here. So these 2 points we have to join by using a straight line. So just we have drawn this one. So this is x plus y is equal to 4. This is an equation line. This line represents an equation. But we have to represent an inequality, x plus y less than or equal to 4. Inequality representation, always you know that it is a region. Maybe it is below the line or above the line. There must be a region which satisfies the equation. So we have to find out. For that verification you have to do, just to take a point on your graph. Here I am taking the easiest point, that is 0, 0. This 0, 0 is lies below the line. The region is below the line. This is your line. This is the equation, x plus y is equal to 4. I am taking a point 0, 0. This point 0, 0 lies below the line, straight line. So when you put 0, 0 on the given inequality, x plus y less than or equal to 4, x is 0, y is 0. So 0 plus 0 less than or equal to 4, 0 is less than 4. So the statement is getting true here. So 0 less than 4, the statement what we have got is true. Means this 0, 0 is lying in the wanted region. Means here this 0, 0 is lying in the wanted region. Then up above the line, that is unwanted region. So what we have to do is just locate that region where this point lies. Just to keep it in your mind, because we have to identify the other two regions also, and we have to shade the common region. That is what we have to do. So our wanted region at present is below this line. Just to keep it in mind, because point 0, 0 we have considered a point below the line, and we got it, the statement true. So this is our wanted region. Means the solution of the inequality lies in this region. Wanted region, just you must have a clarity. Wanted region in the sense the solutions of this inequality lies in that region. Means the solutions are in this region only. If you take a point above the line, this inequality will not be satisfied. So the solution will not lie here. So it will be lying here only. So that is called, it is wanted region. So for this line, this is a wanted region. We have again one more inequality, that is x greater than or equal to 0. X greater than or equal to 0 in the sense, if you consider x-axis, the greater than 0 part comes on the right side of x-axis. That means this portion on the right side of x-axis, that is for this line. And again y greater than or equal to 0. Y greater than or equal to 0 in the sense y-axis positive values, means above this line. So the upper portion of y-axis is the wanted region. So you have to identify the portions which is coming common for first inequality, second inequality, and third inequality. You can just see here, in the first inequality we got below the line, and in the second inequality right side of the x-axis, and in the third inequality above the y-axis. So the common region is this portion, means this triangular portion. So that portion we have to shade. So that is the region which satisfies these three inequalities. So that we have shaded. Then what we have to do is, we have to maximize this value. We have to find out which is the maximum value. Z is equal to 3x plus 4y. For that, what we have to do is, we have to identify the corner points. Means see, you are getting a triangle here, and in this shape we are having three corners. One corner is here, another corner is here, and another one is this one, 0, 0. So let's mark these corner points, and the first point is A, that I am considering as A, and the coordinates we have written 0, 4, and the second point is B40 and third point is 00. Then just make a table, and in that table we have to consider 2 points. One is corner points, those are this 04, 40 and 00. Next is our equation. What equation it is given to us for maximize, or some cases it is minimize. For maximize or minimize, which equation is given to you, that we have to write. Z is equal to 3x plus 4y. Then this 0, 4, x value is 0, y value is 4. You have to substitute in this equation. So in the first point 0, 4, when you substitute x 0, y 4 in the sense, you will get 3 into 0, that is 0, plus 4 into 4, that is 16. Second point is 40. Just replace x and put 4, and y should be 0. So 3 into 4, 12, plus 4 into 0 is 0. So it is getting us 3 into 4 is 12. 12 plus 0 is 12. Next is 0, 0. 0, 0 in the sense, when you replace x, put 0, y replace and put 0. So 3 into 0 plus 4 into 0. 0 plus 0 is 0. We have to find out the maximum value. So just go through this table and we have to identify the maximum value. So the maximum value is 16. We have to label it as maximum. So Z is maximum at the point is 0, 4. Z is maximum at 0, 4 and the maximum value is 16. That is the answer. Next we shall discuss exercise 12.1 second question. Minimize Z is equal to minus 3x plus 4y subject to x plus 2y less than or equal to 8, 3x plus 2y less than or equal to 12, x greater than or equal to 0, y greater than or equal to 0. Here let's write the given statements. Z is equal to minus 3x plus 4y. We have to minimize. Subject to constraints x plus 2y less than or equal to 8, 3x plus 2y less than or equal to 12, x greater than or equal to 0, y greater than or equal to 0. So first of all we have to prepare a table for plotting the points on the graph sheet. So first take x plus 2y equal to 8 equation. This inequality symbol we have to change to equation form. Then as before we can plot the points by taking x is equal to 0. First 0 plus 2y is equal to 8, that is 2y equal to 8, y equal to 8 by 2, that is 4. Next y we can put 0, that is this term completely 0, x is equal to 8 will be coming. Then second inequality we can consider and write it as an equation. 3x plus 2y equal to 12. Table we can prepare. As before x is equal to 0 we have to put first. So that means this term completely 0. 2y equal to 12. Y is equal to 6 will be coming. Next y equal to 0 we can put. Y 0 if you put this term completely 0. That is 3x is equal to 12. X is equal to 12 by 3. That is equal to 4. If you are not feeling comfortable with mental calculation, you can just do rough calculation on the right side of your graph sheet. That is better. So if these points are wrong, your graph will be wrong and the entire answer will be wrong. So when you are taking the points, you must be taken care of the calculations. Otherwise, you will be getting the wrong answers. Next, there are only one variable here, x greater than or equal to 0, y greater than or equal to 0. So plotting points is not necessary. Let's take your graph sheet, draw x-axis, y-axis and plot the points. And plotting points, you have to be very careful when you plot the points. Here you can see x-axis maximum value is 8 and y-axis the highest value is 6. So I have taken in both the axes 8 unit. Then here 1 centimeter I have taken as 1 unit. And in your graph sheet you can consider 2 centimeter as 1 unit, so that your graph will be little bigger and the points it will be easily visible. Then first is 0, 4. First equation when you consider it is 0, 4 first point. 0, 4 in the sense from here 0, 4 is this one. So you must plot the points by using your pencil. Here I am not showing the plotting part and I am directly drawing. So here first point you have to plot. Next is 80. 80 is here. This is 80. So we have to join these 2 points 40 and 04 and 80. Just we have drawn a line. And now we have to find out where is the wanted region. Wanted region in the sense where in which area the solution lies, whether it is below the line or above the line. We have to verify it. So Let's label it first the inequality, then we have to go for verification, that is 0 0. I'm taking a point 0 0. This 0 0 lies below this line. So if I put 0 0 in the inequality, x 3x plus 2y less than or equal to 8, x 0 if you put 0 plus 2 into 0 0 less than or equal to 8. So 0 plus 0 is 0, 0 less than or equal to 8. 0 is less than 8 means the statement is true. Means the point 0 0 lies in the wanted region, means below the line is the region where the solution of the inequality lies. So that just mark that point or keep it in your mind and you can proceed to the next. 3x plus 2y equal to 12. 3x plus 2y equal to 12 is the equation. 0 6 is the first point. 0 6 means comes here. Next point is 4 0. 4 0 is here. So just to plot these 2 points. And as before, we have to go for verification part. Again, the same point only I am taking 0 0 because calculation is easy for us 0 0 if you take. So 3 into 0 0 plus 2 into 0 is also 0. So 0 plus 0 less than or equal to 12. 0 less than 12. Again, the statement is getting true. Means for red line also, the solution lies below the line. Means this portion, this point we have got true. So that portion we have to label it or just keep it in your mind, the area. Next, two inequalities are there again, x greater than or equal to 0. X greater than or equal to 0 in the sense right side of x-axis. 1, 2, 3 are the greater values, positive values. So x greater than or equal to 0 in the sense from 0 to infinity. Means in another way, if you think the right side of x-axis in the sense y-axis right side, this portion completely we have to shade. That is the wanted region for this inequality. Next is y greater than or equal to 0. Y greater than or equal to 0 in the sense 0, 1, 2, 3, 4 y values. Means above the y-axis. This above the y-axis means upper portion of y-axis. Positive side of y-axis is the wanted region. So positive side of y-axis in the sense we can say that above this x-axis portion. This portion, above portion is y greater than or equal to 0. So just combine all these four areas together and just identify where these four areas coming as common. There is a portion which is common for all these four inequalities. So that portion we have to identify. So for this blue line below the line and for this red line also below the line and above this x-axis and right side of y-axis. So all these portions coming together is here. So that particular portion we have to shade. So this is the portion or this is the region which represents 3x plus 2y less than or equal to 8, 3x plus 2y less than or equal to 12, x greater than or equal to 0, y greater than or equal to 0. So after getting this shaded region, just mark the corner points. Here there is one corner point and this is another corner point and here it is third one and this is fourth one. Then write down the points A04, B23, this is 2 and this is 3. So 2, 3. Then here you can consider as C40 and this is of course 0, 0. Then just collect all these points and write it in the corner points column. That is first point 04, next is 2, 3, third one is 4, 0, fourth one is 0, 0. Then z is equal to minus 3x plus 4y. This is the equation it is given to us for minimizing, or we have to find out the minimum value of this equation by using these corner points. So first of all 0 and 4, x0, y4 if you put 0 plus 16. So we will get a 16. Next is x is 2, y is equal to 3. That means 3 minus 3 into 2, that is minus 6 plus 12. Minus 6 plus 12 is 6. Next is 4, 0, x4, y0. So minus 3 into 4, minus 12 plus 0. Minus 12 plus 0 is minus 12. Next is 0, 0. 0, 0 in the sense both the terms will be 0. 0 plus 0 is 0. So just go through these four values and find out which is the minimum value because we are asked to minimize. So the minimum value is minus 12. So just mark it as minimum value, then write the conclusion. So z is equal to minus 12 is minimum at the point 40. Next we shall discuss question number 3. Maximize z is equal to 5x plus 3y subject to
3x plus 5y less than or equal to 15, 5x plus 2y less than or equal to 10, x greater than or equal to 0, y greater than or equal to 0. So let's prepare the tables. First consider 3x plus 5y equal to 15 equation. Then x and y, if you put 3 into x, I am using 0, just similar to the previous question only. X is 0, if I put this term becomes 0. 5y is equal to 15, y is equal to 15 by 5, that is equal to 3. Next to y0 I am putting, y0 putting means this will go as 0. 3x is equal to 15, x is equal to 15 by 3, that is equal to 5. First table is ready. Next we have to prepare 5x plus 2y equal to 10. X and y variables we have taken. As usual, x we put 0, that is 2y is equal to 10, y is equal to 10 by 2, that is equal to 5. Next y0 we are putting, that means this becomes 0. 5x is equal to 10, x is equal to 10 by 5, that is equal to 2. Let's plot it in a graph sheet. X-axis, y-axis we have drawn just to plot the points. As I mentioned before, if you want to increase the size of the graph, consider 2 centimeter as 1 unit. Then just to plot this one, 0, 3, 5, 0. Here it is 0, 3. Next is 5, 0 is here. First of all, you have to mark these points and then you have to join. Then we have to find out where is the feasible region, means where the solution lies, whether it is below the line or above the line. For that we have to take a point 0, 0. Why 0, 0 we are taking, in the sense it is easy for us to calculate, that's why. So 0, 0 we take and put it in the inequality, 3x plus 5y less than or equal to 15. So left side completely it becomes 0, 3 into 0 plus 5 into 0, that is 0 less than 15. It is true, 0 is less than 15 only, means this is our feasible region below the line. So just mark it and label the inequality as well on the top of the line. Next 0, 5, 2, 0. 0, 5 is here, 2, 0 is here. Join these 2 points as before. Take a point 0, 0 and substitute it here. 0 plus 0 less than 10 means 0 less than 10. It is true, 0 is less than 10 only, means this 0, 0 lies in the feasible region, means wanted region. So mark it that portion, label the line as 5x plus 2y less than or equal to 10. Now there are two more inequalities, x greater than or equal to 0. X greater than or equal to 0 in the sense right side of x-axis, means on the right side of y-axis portion completely is wanted region, this portion. Then next is y greater than 0. Y greater than 0 in the sense y-axis above 0 completely wanted region, means above x-axis all wanted region. So all these 4 portions coming together we have to identify. So above x-axis, right side of y-axis, below these 2 lines, the common portion is here. So that portion we have to shade and identify the corner points. Here there are 4 corner points are there, and there is a problem with one point. Let's mark those points first. A03 easily visible here. Next is C20 easily visible, and next is 00 also easily we are able to write. But here there is a point, it is not able to find out the accurate value because the point lies between the smaller lines. So here instead of predicting the values, what you supposed to do is, this point is the point of intersection of two straight lines. Straight lines in the sense these two equations, 3x plus 5y equal to 15, 5x plus 2y is equal to 10. Let's solve these two equations and find out x and y. Solving very simple, any method you can use. 5x plus 2y equal to 10, 3x plus 5y equal to 15. Here I am going to use equating coefficient. First equation I multiply with 3. Second equation I multiply with 5. You know it is better. So if I multiply first equation with 3, 5 into 3 15, 3 into 2 6. Then here 3 into 10, that is 30. Next equation I am just multiplying with 5. 5 into 3 15, 5 into 5 25, 15 into 5 75. Now you see two coefficients are same, so we can eliminate x. When you subtract two equations you will get 6 minus 25, that is 19y, minus 19y, 30 minus 75 is minus 45. So y is equal to 45 by 19 we have got. Substitute this one in any one of the equation. So 5x plus 2 into y, that is 2 into 45 by 19 is 90 by 19 equal to 10. 5x is equal to this, you can take to the right side and do the calculation. You will get us 100 by 19. This 5 and 100 we can cancel it, we will get us 20 by 19. So we can reduce the number of steps and we can write the answer. X value and y value we have to find out, and then just put it here, b 20 by 19, 45 by 19. This is the accurate value. So now we can just prepare the table with corner points. 0 3, 20 by 19, 45 by 19. Next is 2 0. One more point is there, that is 0 0, d 0 0. Then when I put 0 3, if I put 0 3 here, x is 0, y is 3. So this term will be 0, 3 into 3, that is 9. Next is 20 by 19, 45 by 19. When you do the calculation here, 5 into 20 by 19 plus 3 into 45 by 19. Just to take the LCM and find out the answer, you will get the answer as 235 by 19. And divide it, you will get as 12.36. This calculation you have to do it yourself. Next is 20. 20 in the sense, here x value is 2, y value is 0. So 2 into 5 into 2. 5 into 2 is 10. This term is 0. So z is equal to 10. The fourth point we have 0 0. And if you put 0 0, it is no use because 5 into 0 plus 3 into 0, it becomes 0 only. So we want to get a maximum value. So even if you want to write, you can write, or else you can simply neglect it. You can save time. It's not a problem. So now compare these three values. And when you compare these three values, the maximum value is 12.36. So that is the maximum one. So write the conclusion. Z is equal to 235 by 19 is maximum at 20 by 19 and 45 by 19. Next we shall discuss question number 7. Question is, minimize and maximize z is equal to 5x plus 10y. Here we have to find out the minimum value as well as the maximum value. Subject to constraints, x plus 2y less than or equal to 120, x plus y greater than or equal to 60, x minus 2y greater than or equal to 0, x comma y greater than or equal to 0. So here first of all we have to take x plus 2y is equal to 120. This inequality we have to write it as equation. Prepare a table x and y. First x put 0, y is equal to 2y is 120 will be coming, y is equal to 120 by 2, that is 60. Then y0, if I put x is equal to 120 will be coming. Next equation, x plus y equal to 60. Again x and y values you have to take. X0 if I put, y is equal to 60. Then y0 if I put, x will be 60. Next one more equation, x minus 2y equal to 0. From here we have to make. Again table we have to make. Here little bit of, we need to take little bit care because like the previous techniques it will not work here. So x0 if I put, 2y is equal to 0. So y also 0 will get. Now both x and y we have got zeros. So again y equal to 0 is not possible to take like here. So we have to use some other value. So I have taken x is equal to, y is equal to 10. Y is equal to 10 if I take 2 into y. 2 into y is 2 into 10. 2 into 10 is 20. Minus 20 when it comes to the right side it becomes plus 20. So x is equal to 20 we have got. Then we'll go for plotting x and y axis as before and just plot it. Here the highest point is 120 and another point is here 60 on the y axis. So I have taken here as 20, 40, 60, 80 on the y axis, 20, 40, 60, 80, 100, 120 on the x axis. Here x axis and y axis I am using two different scales, but when you are drawing it on your graph sheet you can use the same scale. It is not a problem. Here when we draw, first one 0, 60 and 120 0. 0, 60 in the sense 0, 60 comes here first point. Next is 120 0 comes here. So when you join these 2 points you will get a straight line like this. Then we have to find out the feasible region. Again 0 0 if I take here, 0 0 is below this red line. 0 0, if I put 0 plus 0 less than or equal to 120, means 0 less than 120 statement is true, means below the line is wanted region or feasible region. So label the line x plus 2y less than or equal to 120. Next is x plus y greater than 60, greater than or equal to 60. Here 0 60, 0 60 in the sense 0 60, again the same point only. Then 60 0, next point is here. Join these 2 points and again taking the same point 0 0. If I put here 0 plus 0, that is 0 greater than 60. Here 0 greater than 60 will be coming. 0 greater than 60 is not true, it is false, means this 0 0 lies not in the feasible region. Just opposite side of that particular line is the feasible region, because this one is wrong. The inequality shows wrong when we substitute a value from here, means this is not our wanted region. Wanted region will be just opposite of this one, means this portion. So that portion we have to mark it and label the line. Next one is x minus 2y greater than or equal to 0. That equation is here, x minus 2y equal to 0. Just to plot it, 0 0. One point is here, another point is 20 10. 20 10 is 20 is here, 10 is here. So by connecting these 2 points we will get a line like this. Then we have to find out the feasible region. Feasible region, for finding that region, 0 0 is not possible to take because the line is passing through 0 0. So we have to take some other point. So I am taking a point 20 0. Only this portion verification I am doing. The other portions I have done mental calculation. So this one I have taken another point 20 0. This point I have taken. And when I substitute x minus 2y greater than 0, 20 minus 0 greater than 0, that is 20 is greater than 0. 20 is greater than 0 in the sense it is a true statement. Surely 20 is greater than 0 only. Means the point lies in the feasible region. Means below the line is our wanted region. So label it that one. Then label the line as well. Then two more inequalities are there. X greater than 0, y greater than or equal to 0. So as I mentioned before, x greater than 0 means right side of x-axis, or we can say that the right portion of y-axis portion. This portion is complete wanted region. Then y greater than 0 in the sense the upper portion of y-axis. So those portion is wanted region. So all these 1 2 3 4 5 inequalities, the regions coming together, that portion we have to shade, that is this portion we have shaded. Then as before we have to go for finding out the corner points, and here corner points are quite simple and we can easily write from the graph. So here 40 20, then here is 60 30, then here it is 120 0, and here it is 60 0. Now just pick and write the corner points, that is 60 30, 40 20, 60 0, 120 0. And z is equal to 5x plus 10y. We have to minimize and maximize. Minimum value and maximum value we have to find out. When you substitute 60 30, x is equal to 60, y is equal to 30. So 5 into 60 300 plus 10 into 30 300. So 300 plus 300 600. 40 20, x 40, y 20. So 5 into 40 200 plus 10 into 20 200. 200 plus 200 we will get 400. Next is 60 0, x 60, y 0. X 60 in the sense 60 into 5, that is 300 plus 0. 300 plus 0 is 300. 120 0, x 120, y 0. So 5 into 120, that is 600 plus 0. 600 plus 0 is 600 itself. So when you observe here, 600 is the highest value. So two maximum values are there, 600 at two different points. One is 120 0, another one is 60 30. One minimum value, that is 300. So let's summarize it. Z is equal to 300 is the minimum at 60 0, and Z is maximum at 2 points. One is 60 30, another one is 120 0. So this is the conclusion. And the maximum value also we have to write, that is Z is equal to 600 is the maximum at all points joining 60 30 and 120 0. So this is our conclusion. Next we shall discuss question number 10. The question is maximize z is equal to x plus y subject to x minus y less than or equal to minus 1 minus x plus y less than or equal to 0 x comma y greater than or equal to 0. So first of all x minus y is equal to minus 1. This inequality we are writing as equation. Let's prepare it. X and y. X is 0 when we put, y is equal to 1 will get, and here y when you put 0, x will be getting us minus 1. So since we are getting a minus 1 value, we are not taking that one, because in our graph we are plotting x and y values, positive values only. So just avoid that y is equal to 0 value, and some other value we can put. Here I am just taking y as 3. Y is equal to 3. If you put x minus 3 is equal to minus 1. So x is equal to this minus 3 will come to the right side as plus 3. So minus 1 plus 3 is 2. So our points are 0, 1 and 2, 3. Then minus x plus y is equal to 0. This inequality we are taking and writing as equation. Then as before we are taking x and y. X 0 if I put, y is also 0 will be getting. So since y we have already got 0, there is no chance to put again 0. So we have to use some other value. y1 I am putting. y1 if I put, this minus x is equal to minus 1 will be coming. Minus minus cancel, x is equal to 1 will be getting. Now let's plot these points in the graph sheet. First point is 0, 1. Then next is 2, 3. So 0, 1 and 2, 3 if I plot, the line will go like this. And next we have to go for verification part. I'm taking a point 0, 0 which is below the line. 0, 0 if I put x minus y less than or equal to minus 1. In the sense if I put 0 minus 0 less than minus 1 will be coming. 0 is less than minus 1. 0 is not less than minus 1. So the statement is false. Means this portion is not in the feasible region. If this portion is not in the feasible region, means our feasible region will be opposite of this point, means above this line. So that line, that portion we have to mark it and label the line as x minus y less than or equal to minus 1. So that portion we have to shade it. Next is minus x plus y equal to 0. We are going to represent 0, 0. This is 1 point, 0, 0. Next is 1, 1. 1, 1 will be coming here. So by connecting these 2 points, we are drawing a line. And again, we are going for a verification part. Since the line is passing through 0, 0, it's not possible to take that point. So I'm taking another point, 2, 1. 2, 1 in the sense this is the point. So below red line. The point lies below the red line. So minus 2 plus 1 less than or equal to 0. That means minus 1 less than 0. Minus 1 less than 0 means the statement is getting true. Means that point 2, 1 lies in the feasible region. Means this is our wanted region. So that portion we have to shade. And here there is no common portion. When you look at x greater than 0 and y greater than 0, x greater than 0, as I have told you, that it is the positive side of x-axis, means the right side of y-axis, and y greater than 0 in the sense above x-axis. So there is no portion is coming common which satisfies all these 4 inequalities, because this line goes upwards the feasible region and for red line downwards the feasible region. So there is no common portion is available. So as there is no common region, there is no feasible region. Thus z has no maximum value. So that is our conclusion. Dear students, today we have discussed problems from exercise 12.1. Hope it is clear for you all. If you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.